Okay, so you know the new half angle formulas. Let's talk about how to deal with them. So on this problem, we already have the given information recorded, and I can go ahead and say that the cosine of theta over 2 formula is plus or minus the square root of 1/2 times 1 plus cosine theta. Now, you don't keep the plus or minus symbol in front of the square root. You have to make a conscious decision about whether to carry into the next steps the positive or the negative. So here's how you do it. I'm going to look and I'm going to say, all right, if theta as I've pictured it is in quadrant 3, then theta falls between 180 degrees and 270 degrees. So if I divide everything by 2, I now know that the angle theta over 2, or like 1/2 theta if you want to think of it that way, falls between 90 and 135 degrees. Well, that puts the theta over 2 angle in quadrant 2. Okay? Well, cosine of this angle, which I now know is in quadrant 2, would be negative. And if it's negative, I select the negative, not the positive, to carry forward into the remaining steps. So now I'm going to say more specifically, I've said positive when I meant negative. I say more specifically negative. Now, I've got to say 1/2 times 1 plus. Now look, guys, this is asking for you to do cosine of theta right here, not theta over 2. So it means the theta in the triangle. Well, cosine of theta is negative sitting in the tangent quadrant. More specifically, it's negative 7/25 from the black triangle that's pictured. So you're dealing with the sine of cosine of theta over 2 and the sine of cosine of theta within the same problem. That's tricky. So I'm going to say it's negative. Now, on the inside of the parentheses, let's read this. One is 25/25 plus a negative, or minus 7/25. So that's going to be 18/25. I'm going to say half of 18 is 9/25. And then that turns out nicely as negative 3/5. So intentionally choosing the sign that goes with cosine theta over 2 or sine of theta over 2 is tricky. Any other sign for any other formula just works itself out. So for instance, the formula for tangent of theta over 2 needs to be expanded into 1 minus cosine of theta over sine of theta. Guys, you do not have to choose whether this works out to be positive or negative. It'll naturally work itself out. Now, I can tell, again, from the previous problem, theta over 2, this is the same given information. So theta over 2 is in quadrant 2. So tangent of theta over 2 is going to be negative. So 1 minus cosine theta over sine theta will naturally work itself out as sine theta, so you don't have to make those decisions. So I'm going to say 1 minus. Now, I just did cosine theta a second ago. See here in blue? Cosine of theta is negative 7/25. So 1 minus negative 7/25. And sine of theta, if you look at this black triangle, sine of theta is negative 24/25. So the top was going to be 25/25 plus 7/25, which is 32/25. The bottom is negative 24/25. The 25s will cancel. So I'm going to have negative 32 over 24, divide by 8, so that will be 4 over 3. Okay? And again, notice the negative just worked itself out on this one. So the only formulas for which you must be very intentional about selecting the sine are the sine half angle and the cosine half angle problems. So what other half angle problems do we need to go through? Take a look at the 1 minus cosine of 540 all over 2. Do you recognize that this is the formula for sine of theta over 2? Okay, so again, I'm thinking that plus or minus the square root of 1 minus cosine theta over 2 is equal to sine of theta over 2. That's what I'm thinking of. So the problem at hand is going to be sine of theta. Do you see that 540 is what I was given over 2? Well, half of 540 is 270. Oh, and I know that because on the unit circle, remember 270 is down here, and that point 0, negative 1, and sine's y. Here we go. So we've got that one worked out. Now, yesterday, we skipped on the Promethean board this problem. Well, let me think for a minute. This is in the form 1 minus tangent squared theta over 2 tangent theta. Well, that's not a half angle formula. Do you notice that we have the formula 2 tangent theta over 1 minus tangent squared theta? We know that one. That's the formula for tangent 2 theta. So if this formula that I'm giving you is the reciprocal of the formula I've written down, wouldn't this be the reciprocal of tangent 2 theta? Oh, look at what I've got. This is cotangent 2 theta. See where we're headed with this? So that means the problem that I'm giving you is the cotangent of 2, and your theta is 67.5 degrees. Well, 2 times 67.5 is 135. 135 degrees is a major angle, and so I can just say that that is negative, because we're in the sine quadrant, 1, because you've got to do cotangent 45 degrees. All right, so we're making progress. Now, handy tips. If you use the half angle formulas, it allows you to do some new angles. So you can do half of all your 45 degree angles, which you couldn't do before. So half of 45 degrees gives you 22.5 degrees. If you also did half of 135 or half of 225 or half of 315, you would get 0.5 degree angles on all of those. Those are new. If you think of half of pi over 4, if you think of it in terms of radians, you get pi over 8. So guys, I'm going to be able to now do angles, sine, cosine, tangent, secant, cosecant, cotangent, of angles that end in 0.5 degrees if they happen to be half of a 45 multiple, or that end in pi over 8, okay? I couldn't do those before. But now listen, if you're going to use, if you're going to have an angle that ends in pi over 12, or is a multiple of 15 degrees, these angles could have been done yesterday. They can also be done today. So when you have a choice, this first tip says that the sine of a plus b and the cosine of a plus b formula is much easier to work with than the new sine half angle and cosine half angle formula, if you have a choice. If you have like a pi over 8 angle, though, you don't have a choice, because we could not do those yesterday. So those you'll have to do the half angle formulas for. But listen, anytime you do a tangent problem, you can always do tangent of the half angle formula, which is the best formula we've got. So from now on, I won't use the tangent of a plus b formula for evaluation purposes. Okay? So let me show you what I mean. Now, sine of 22.5 is the same as sine of 45 halves. There is no other way to get this. So the half angle is required. I cannot get around it. Okay? So that means I'm going to have to set up and go, okay, well, I know it's plus or minus a half times 1 minus cosine. Theta, in this case, is 45. Now remember, you do not carry the plus minus. You decide right now, is it positive or is it negative? Guys, sine of 22.5 degrees is going to be positive because 22.5 is in quadrant 1. So from here on out, I'm carrying the positive, not the negative sign. So let me go ahead and proceed and say positive. I'll eventually not write that down, but I want to make sure that I'm being clear that I've thought about it. Cosine 45 I know is square root 2 over 2. So I'm fixing to get an answer with tons of 2's in it. So let's see here. I'm going to say that is 1/2 times 2 over 2 minus square root 2 over 2. So think of 1 as 2 over 2. So that gives me 2 minus the square root of 2 all over 2. Well, that gives me, if I multiply across the top, 2 minus the square root of 2 over 4 when I multiply across the bottom. One more step. The square root of the top is the square root of 2 minus the square root of 2. I can't do anything with that to make it better. The square root of the bottom is just 2. So that's my answer. Now, FYI, my options for any of these problems where you do sine or cosine of a pi over 8 or a 0.5 kind of angle, you're either going to have 2 plus the square root of 2 all over 2, 2 minus the square root of 2 all over 2, that's what I just got, right? Or you're going to have negative square root of 2 plus the square root of 2 all over 2, or negative square root of 2 minus the square root of 2 all over 2. So it comes back down to all the answers look alike except for changes in signs. And of course the one I just got was this one for this particular purple problem I just worked. Now, cosine of 7 pi over 8 is similar. Cosine of 7 pi over 8 is the same thing as cosine of half of 7 pi over 4. The only way you can do the pi over 8s or the 0.5s is to do a half angle. So the half angle is required, okay? I cannot get around it. This is one of the few times you can't get around it. So I'm going to set up and say that's plus or minus the square root of 1/2 of 1 plus cosine theta is 7 pi over 4. That's the angle I've halved in the original problem. All right, so again, I have to be very intentional about whether the sign is positive or negative. So let me do some calculations. I know that 7 pi over 4 is the same thing as 315. So half of 7 pi over 4 is 315 degrees divided by 2. So what's that going to be? Half of 315 is, or half of 300 is 150. Half of 15 is 7.5. So that's going to be 157.5. So I'm saying 7 pi over 8 is the same thing as 157.5. Well, the cosine of 157.5, since this is in the sine quadrant, will be negative. So that means I've got to choose the negative. Phew, hard part over. Now I know that one of these black answers that I've listed to the left is going to be my answer. Well, in fact, I know it's going to be one of the two bottom answers that lead with a negative in front. So let's go through it. I've got 1/2 times 1 plus. Now, 7 pi over 4 is in the cosine quadrant, so this will be positive, and it'll be positive root 2 over 2. So it's going to be negative 1/2. If this is 2 over 2 plus root 2 over 2, it's 2 plus the square root of 2 all over 2. I'm going to make this a little faster now because I know what to expect. On the top, I just get 1 times 2 plus the square root of 2. And the square root of that's just the square root of 2 plus the square root of 2. I can't do anything with it. On the bottom, I get 4, but I take its square root and get 2. So now you see that it matches the second black answer that I had gotten, okay? So those are messy. They are tedious, I know. Fortunately, they don't come up on their own a whole lot, which is nice. Now, 165, I've got a choice, okay? Because think about it. If we went with what we did yesterday, I could say, well, how about we just do 45 plus 120? And there's other ways I could do that as well. I could say 135 plus 30 and so on. There's a whole lot of ways I could work it out. Now, if I multiply 165 times 2 real quick, okay? So that's 10, 12, 13, and then what, 3? Okay? I could look at 165 as if it's half of 330. So I can still do the half angle formula. Okay? Don't really want to, but I can. Let me work through this and prove to you that you really don't want to do this if you've got a choice. This is what I was saying on tip number 1. So I start out with crazy half angle formula. This time my cosine theta would be cosine 330. It's always cosine of the angle that you already know how to do. So I have to be intentional about picking my sign. Well, 165 again is in the sine quadrant, so I know the answer is going to be negative. So I have to choose the negative sign to carry forward. Okay? So I'm going to say negative. I've got 1/2, 1 plus. Now look, 330 is in the cosine quadrant, so that's going to be positive. Cosine 30 is square root 3 over 2. All right, so I'm going to keep going. Look at this one as if it's 2 over 2. So the top will be 2 plus the square root of 3 all over 2. If I multiply across the top, I just get 2 plus the square root of 3. I take the square root of that and get the square root of 2 plus the square root of 3. When I multiply across the bottom, I get 4, but I take its square root and just get plain old 2. Now, that is a good answer, but it's not very usable, nor was it easy to get to. So look what happens if I rebound back to what I did yesterday. I get cosine, cosine, minus sine, sine. So cosine 45, cosine 120 will be negative because you're sitting in the sine quadrant, 1/2. Sine 45, sine 120 is positive. That gives me negative square root 2 minus the square root of 6 all over 4. Not only was that less stressful to work with, to get to, it's also going to be easier to use as in future, when we go in future chapters and we use these values for things. This is the easier one to use, so this is faster to get to. The answer is more usable. So this is my point on tip number 1. When you actually have a choice between going back to a sum or difference formula or using a new half angle formula, for sine and cosine, do the old stuff. So don't do the half angle formula unless you're dealing with something that ends in 0.5, which is going to be half of a 45 multiple, or you're ending with something that ends with pi over 8, so it's half of a pi over 4 multiple. Otherwise, do not use these crazy half angle formulas because they're painful. They really are. So, for sine of 11 pi over 12, do you recognize that I can make it half of 11 pi over 6, but why would I? All right, pi over 12s are something that we did a couple of days ago. So again, I'm not going to do this whole problem, but I'm gonna go, use some difference because you can. Stay away from those half angle formulas because they're tedious and the answers are difficult to work with when you go to later chapters. So I'm going to think through now. 11 pi over 12. I could break it up again as 1 pi over 12 plus 10 pi over 12. That doesn't work because pi over 12 I don't just know. I could break it up as 2 pi over 12 and 9 pi over 12. Now wait a minute, that would be pi over 6 and divide by 3, divide by 3. Yeah, I can do these. That works. So I personally am going to break it into the sine of pi over 6 plus 3 pi over 4. And then I'm going to hit it with my sum and difference formulas just like I did yesterday. So on the worksheet, do what's easiest. Don't practice the thing that's going to be a pain. Just do what's easiest. Now, with tangent, from now on, use half angles. So this is tip number 2. With tangent problems, when you're evaluating like we are now, use half angles all the time. So the tip about use a 60-degree reference angle instead of a 30-degree reference angle, that was a one-day fix. I can do you better now. That's the whole point. I can write this as tangent of half of 7 pi over 4. Well, that's going to be 1 minus cosine theta. Your theta is 7 pi over 4 over sine theta. And I'm going to show you a trick, okay? So 7 pi over 4 is in the cosine quadrant. So cosine 7 pi over 4 is positive. Sine of 7 pi over 4 is negative, but it's still square root 2 over 2. All right, I think what I'm going to do is separate and reduce. So I could say it's 1 over negative square root 2 over 2. And it's going to be plus root 2 over 2 over root 2 over 2 because it's going to be negative over a negative. So 1 over means reciprocal. So that would be negative 2 over root 2 multiplied by root 2 over root 2. Do you see that's going to be 2 root 2 over 2? And then this other one's going to be plus 1 plus 1. This cleans up then to negative root 2 plus 1. Okay? I'm going to show you something that I do that I think is a little bit easier. Same problem. I just think it's easier. So I'm still going to use this, but I'm going to write my next step as 1 minus. I'm going to write root 2 over 2 on the bottom or on the top. But since I'm going to have to flip the bottom, I'm going to write it as unrationalized 1 over root 2. Because then that's the same thing as saying, instead of dividing by 1 over root 2, multiply by root 2 over 1 and make it negative. Okay? That's easier to distribute. Because then negative root 2 times 1 is negative root 2. And negative root 2 here is going to be positive 2 over 2, so positive 1. So that's my trick for trying to speed these up. But I'm telling you, the tangent half angle is always easy to work out. And it works on every single evaluate problem we have. So for instance, I'm going to do the same thing and say this is half of 210. 105 degrees is half of 210. So I'm going to break it into 1 minus cosine 210 over sine 210. Now, 210 is in the tangent quadrant, so cosine's negative. It's going to be negative cosine 30. 210 still in the tangent quadrant, so sine is also negative. So rewrite your top as 1 plus the square root of 3 over 2. Instead of dividing by 1 over 2, multiply by 2 over 1, and it's negative. Now distribute. So negative 2 times 1 is negative 2. Negative 2 times positive square root 3 over 2 is positive square root 3. Negative square root 3. I just realized what I said, sorry. And that still falls in line. Remember, we said a couple of days ago when you do the 15-degree multiples, you're either going to get 2 plus square root 3, 2 minus square root 3, negative 2 plus square root 3, or negative 2 minus the square root of 3. Those were the numbers we came up with. And so I am getting one of those 4 on that problem. Now, otherwise, you can go right back to doing what we did the other day and saying 60 plus 45 and go through it. There's nothing wrong with this, but I'm telling you, if you'll just, for evaluate purposes, stick with the tangent half angle formula, you'll get really fast at it, and it's easier and faster than what I'm doing right now. And what I'm doing right now is not actually bad, but it's still more. So it's going to be root 3 times 1 right there. It's still more than I have to do. And that's the point. I'm trying to just give you tricks about how to make these things not quite so painful. So first, outer, inner, last. This is not bad because everything's turning out positive, a squared minus b squared. So my numbers are pretty simple, and it's still going to wind up taking me longer in the long run. So 2 square root 3 plus 4 over negative 2. So 2 divided by negative 2 is negative 1 square root 3. 4 divided by negative 2 is minus 2. So I'm getting the same answer, but if you'll work with the green half angle option, you're going to move faster overall. You'll get really good at it. That doesn't mean you don't need to know the tangent of a plus b formula. It'll come up in other sorts of questions. You just don't need it for evaluate purposes. Now, let's look at the 1 minus cosine 8x over sine 8x. Do you recognize this as 1 minus cosine theta over sine theta? Oh, and we know that that is the formula for tangent theta over 2. Okay? That's what I'm thinking about. So now I'm going to apply the formula to the actual problem that I'm giving you. So I know that's going to be tangent of theta over 2. My theta is 8x over 2. So this one simplifies to tangent 4x. See, that's not bad. The half angle formulas aren't bad in a case like this. All right, we did these yesterday, so I'm just going to skip. Okay, so we've only got this one last proof. Then you're going to spend the rest of your time today just trying to finish up the double and half angle worksheet and then moving on and working on your A51, which is a test review. You may want to work together to correct and review your old tests because remember, you're going to be doing your, the test on Monday will be over all the identities, all these sum and difference formulas and double and half angle formulas plus the old tests. All right, so on this one, you can really start on either side, but as you've heard me say before, it is easier to take something big and wheedle it down to something small. So this fraction, I think, will be easier to take down to a monomial instead of trying to blow the monomial up, although it is doable. So when I look at this, I'm thinking, well, the other side, tangent theta, just has 1 thetas in it, so it looks like I need to expand. Well, sine 2 theta expands to 2 sine theta cosine theta. Now, right here, I want to show you some options, okay? If I expand cosine 2 theta, I could make it cosine squared theta minus sine squared theta. And that has benefits, but consider option 2. Option 2 is 2 sine theta cosine theta over 1 plus, this time I'm going to make it 2 cosine squared theta minus 1. Okay? Option 3 would be for the top to be 2 sine theta cosine theta over 1 plus, cosine 2 theta can also be written as 1 minus 2 sine squared theta. Now they all have options, but do you recognize that a fraction that has a monomial on the bottom is always easier to manage? So I choose to go purple because this gives me 2 sine theta cosine theta. And look, the ones cancel, leaving me just 2 cosine squared theta. So that monomial makes it easier because the 2's reduce out. The cosine theta and the cosine squared theta simplify to where you have sine over cosine, and that's tangent. So when you have to expand cosine 2 theta, you can usually do it in any direction, but it sure is nice if you can kind of toy around until you get a bit adept at figuring out which way is going to work. All right, guys. Sorry that we didn't get all this finished yesterday. I hope you're good, and the rest of your time is work time, so really make the most of it. I'll be here Monday really early, and I can answer any homework questions, and we can go over, I can throw out problems that we've done on tests in years past. If you're doing an AP exam on Monday and I don't see you, good luck, and we'll figure out how to make up the test later.